Hi, my name is Bryan, and if you're designing a control system with a Rockwell Micro800, right out of the gate you've got a big decision to make. When you need more I/O, how are you going to add it? The platform gives you two powerful but very different options. Today, we're going to break down exactly how to choose the right one for your job. Let's jump right into it. This isn't some tiny technical detail you can gloss over. This choice has a real impact on your panel size, your budget, and how easy that system is to work on down the road. Getting this right from the start saves you a world of headaches later. Here's the game plan. We're going to meet the modules, do a head-to-head comparison of their key differences, walk through some real-world application scenarios, give you a practical checklist, and even peek at how you can expand your options beyond just the standard catalog. First, let's get a clear picture of our two controllers. They both expand what your controller can do, but they are built for fundamentally different jobs. Think of plug-in modules as little integrated specialists. They physically snap right into the face of the controller, connecting directly to its backplane. That direct connection is the key. It gives you incredibly fast, low latency communication between the module and the CPU. This is where they really shine. Plugins don't take up any extra DIN rail space, so they're perfect for adding specific specialized capabilities, precise analog inputs, thermocouple measurements, or a communication protocol like BACnet, all without making your panel any bigger. On the flip side, expansion I/O is all about scale. These modules connect to the side of the Micro800 and line up on the DIN rail, creating a chain that can massively increase your system's total I/O count. This is your go-to solution when an application demands a high volume of I/O ports, dozens or even hundreds of sensors and actuators on a large conveyor or a complex packaging line. It's the standard approach when the base controller just isn't going to cut it on its own. Looking at them side by side, the fundamental difference is physical. One lives on the controller and is built for specialized functions in a tight space. The other lives next to the controller and is built for scaling up I/O count. Capability versus capacity. Keep that distinction in mind as we go deeper. Now, let's put them head to head and break down the four most critical factors you need to weigh when making this choice. Physical setup. Expansion modules consume it. I/O capacity. With plugins, you're limited to 2 or 5 slots on the controller itself. With expansion I/O, you can scale significantly. Function type. Plugins are your specialists. Expansion modules are your workhorses for high volumes of digital and analog points. Communication path. Plugins talk directly over the backplane for the absolute lowest latency. The expansion bus is still very fast, but there is a small measurable increase in delay. Now, let's see how this plays out in the real world, because application is everything. 3 scenarios make the logic clearer. On a compact machine skid, where every square inch of panel space matters, you need thermocouple input and an analog output. That's a perfect job for 2 plug-in modules. Imagine a sprawling conveyor system with photo eyes and motor starters everywhere. This calls for expansion I/O. And a modern HVAC system is often a hybrid, a plug-in for the specialist BACnet communication to the building management system, and a bank of expansion modules for all the fans, dampers, and sensors. It's about using the right tool, or sometimes the right combination of tools, for the job. To apply this on your own projects without guessing, here's a simple 4-step checklist. Step 1. Analyze your I/O count. Get a hard total for all digital and analog points. That tells you your scale. Step 2. Identify your function types. List any specialized needs. Think BACnet, high-speed counters, RTDs. This defines your capability requirements. Step 3. Evaluate your panel space. Is DIN rail real estate a hard constraint? Step 4. Match the module to the function. Your list from step 2 points towards plugins. Your count from step 1 points towards expansion. It's that straightforward. But what if your list of specialized functions includes something that the standard Rockwell catalog doesn't offer? You're luckily not stuck. This is where third-party developers like Spectrum Controls come in. Both plugins and expansion modules that are fully compatible with the Micro800. offering unique functions you can't get otherwise, like universal analog inputs or direct thermistor connections. These aren't awkward workarounds. They're designed to integrate seamlessly into connected components workbench, carry the industrial certifications you need, and include options for Class 1, Division 2 hazardous locations. They're a legitimate and powerful way to extend what your system can do. After all of that, it comes down to one principle. Plug-in modules equal specialized capability. Expansion I/O equals sheer point count. The most effective, efficient, and maintainable systems come from matching modules to the job the system actually needs to do. Apply that function-first logic, and you'll design a better, smarter system every time. Thank you for watching. If you enjoyed the video, make sure to leave a like and subscribe to Automation Nation. If you have any questions, drop them in the comments down below, and one of our specialists will answer them. See you next time.